This chapter starts up with procedural and declarative knowledges comparison part. This is an extension of lecture number 8. After lecture number 8, progressively we had uh, quite a number of lectures which were mm, um, related to frames, semantic nets, then frames, slots, frames part 2. All these things were there, right? Now, lecture number 8 was left on this slide. That means the knowledge type. Let us see that before coming up to this slide, what are the things that we have gone through. We started up this chapter of knowledge representation from here. We talked about what are the types of knowledge and how knowledge arises. At that point of time, the different types of knowledge, while we talked about logic rules, which we have already gone through in our classes, and frames and semantic net is the part that I have covered in depth and in detail in the lectures that came after lecture number 8. Then we had the migration from data to wisdom. This is one of the part that we have dealt in lecture number 8. We talked about data, its examples, we talked about information, we talked about knowledge, and we talked about wisdom. We talked about the various knowledge models, the Bellinger's model of 1980, how it moved on. We talked about all these things. We talked about now. The important thing that we talked about was knowledge category. They are basically of two types, the tacit and the explicit knowledge. The tacit knowledge is called as the informal knowledge or implicit knowledge, and the tacit knowledge is called as the formal knowledge. We have already gone through all these things in lecture number 8. Kindly go and see it, or you can visit it once, right? The difference between tacit knowledge and explicit knowledge is that tacit knowledge exists within a human being, it is embodied, and explicit knowledge is outside the human body, right? It is outside the human body. It is difficult to articulate, and that means tacit knowledge. And explicit knowledges cannot be articulated formally. Tacit knowledge is difficult to be communicated and it can be spread very easily. That means explicit knowledge, right? We talked about this knowledge topology map also, and I have also said you that these kind of questions can come up in your examinations. We talked about the explicit, the tacit knowledge, the information and its correlations, right? Then we have gone through all these things. We came to the knowledge type and we left the things here. I just gave you a very small revision of what we have gone through and what was the gap, and in that gap what are the things that we have covered that I have talked about. Now, procedural and declarative knowledge, we have gone through it many number of times, but in the perspective of knowledge representation, how to do something, it is procedural knowledge, and that something is true or false, that means assertion based, it is the declarative knowledge. If I have to say that I have to determine between Peter and Robert who is older, then first thing that I have to do is I have to find out their ages, and then on the basis of that I have to come to a conclusion that who is older. In case of declarative knowledge, the car has 4 tires and Peter is older than Robert. Straight away I assert these things. Now, focuses on tasks that must be performed to reach a particular objective or goal, and it refers to the representation of the objects and events, right? Examples are procedures, rules, strategies, agendas, and models. The examples of the declarative knowledges: concepts, objects, facts, propositions, assertions, semantic nets, logics, and descriptive models. Now comes this important stuff, that is the relationships among the knowledge type. The relationship among what? The explicit, implicit, tacit, declarative, and procedural knowledge is illustrated below. You have to understand and then remember this diagram. Let us start off from here, the top. Knowledge start, that means you have gained some fraction of a knowledge. Can this knowledge be articulated? And if it has been articulated and it is yes, I call it as an explicit knowledge. We have just now, a few minutes back, we have revised that what is an explicit knowledge. If this knowledge that has been articulated, that means has been articulated, no, it has not been articulated and cannot be articulated further also, yes, then it is implicit knowledge. Cannot be articulated, no, that means it can be articulated, then it is tacit knowledge. So now we are having the basic knowledge, that is the tacit and the explicit knowledge. This is an extra addition of the implicit knowledge, which we haven't talked about earlier. And tacit, the explicit knowledge is nothing but the declarative knowledge, and the tacit knowledge is nothing but the procedural knowledge. Procedural knowledge comes up from what? Now, motor skills, that means manual, that means through experience over ages. This thing you cannot give to others. These are some of the definitions that are already there previously. You can go through the lecture number 8. Procedural knowledge is gained by doing something, that means mental skill, whereas declarative knowledge is through facts and things, tasks and methods. It is by describing something we come to the declarative knowledge. So you need to understand this diagram and you have to remember this also. This diagram basically consists of the knowledge start, the explicit knowledge, the implicit knowledge, the tacit knowledge, the declarative knowledge, the procedural knowledge, and how they are formed, right? By doing certain kind of articulations. Whether the articulation can be done further or not, on the basis of this decision, we are assigning the class of the tacit or implicit knowledge. And then if the knowledge is gained by doing something, call it as a procedural. If it is by describing something on the basis of the facts and figures, we call it as the declarative knowledge. So this is nothing but, this figure is all about the relationship amongst the different types of knowledge. This is just the description part of it, which I have already said you. The figure shows declarative knowledge. It is nothing but describing. It also talks about the procedural knowledge. It is about doing something. The vertical arrows connect the explicit with the declarative and tacit with the procedural, indicate the strong relationship that exists among them. Horizontal arrows connect the declarative and the procedural knowledge, and it also talks about what the procedural knowledge is a result of starting from the declarative knowledge itself, and to know about and then know how. Therefore, we may view all the procedural knowledge as tacit knowledge, we are concluding it here, and the declarative knowledge as the explicit knowledge. Now comes the framework for knowledge representation, or the framework of knowledge representation. It was given by Poole in 1998. A computer generally requires a well-defined problem for solving it further, right? For doing so, we need to collect the information. The information can be gained in small fragments, or it can be processed from the spoken language itself and then represented in the form of a formal representation, so that it can be used by the or processed by the computer. Now this process that I have said you now can be illustrated by this diagram. In this diagram, we are having a central thick line, which you can see here, this pink color line, right? We are having a pink color line. Above it, we are having the problem and its solution. This is an informal approach. I am given with a problem, I'll be solving it, and I'll come down to the solution part of it. But if I come from problem to its representation by representing it, and then this represented problem can be computed to give an output, and this output's formal representation is nothing but the solution. So in all the way, you can start off from problem to its representation to output, then to solution, or straight away from the problem to solution. So the basic difference between these two is on being either side of this pink line. On the above part of it, we do have the informal part, and below it we do have the formal part of it. So this knowledge representation framework may also be asked to you during the examinations or during your assignments, right? Kindly go through it, try to understand it from the explanations, and try to remember it also. Now, here there are some theoretical parts like the informal formalism of the problem takes place first. These all things we have gone through the NPTEL lecture notes from lecture number 9 onwards, right? The problem solving requires formal knowledge representation, conversion of informal knowledge to formal knowledge, conversion of implicit knowledge to explicit knowledge. And knowledge representation is nothing but it is a description of the world, which is systems competence. This is there in the first slide itself or the second slide, and the representation is nothing but the system's performance. If you want to check it, just you can get back here. You can get back here. Here in slide number 2 itself, it was there: systems competence and systems performance. So this is over. Now, in a simple words, we can say that we need to know about the things we want to represent and need some means by which things can be manipulated. Now, know things to represent our objects, events, performance, and meta knowledge, that means knowledge within the knowledge, and need means to manipulate, that means it requires some formalism. These formalisms I have already talked about in your frames, slots, semantic nets, etc., right? Thus, the knowledge representation can be considered in two levels. The first one is the knowledge level, the second one is the symbol level. You need to remember this. A good representation enables fast and accurate access of the knowledge and understanding of the content. Now, mapping between facts and representations, the most important thing is out here. I'm just running a little fast, right? There are facts to symbols, mapping of facts to symbols, and symbols to facts using forward and backward representation mapping, which I have gone through earlier through practical examples. Now, this is nothing. This is our predicate representation. Spot is a dog. Spot is a dog. How is English language represented in the internal representation, and then to the facts. These all things are not to be described now. See, you have gone through all these things before in the class itself. Now we do have the forward and the backward representation, right? The forward and the backward representations are initial facts, when we do have the initial facts, and a desired real reasoning. Then I can straight away come up to the final facts. But I can have the internal representation of it operated by a program, and then I do have the English representation. So moving on to the internal representation, from the initial facts, it's a forward representation mapping, and then after it has been operated by the program, when we have reached for the English representation, I can go by the backward representation mapping and I can reach to the final facts, right? Now, the dotted line on the top indicates an abstract reasoning. This is not a formal one, this is an informal one. So we are talking about the abstract reasoning part here, whereas the concrete reasoning part are represented by the solid lines. So basically it is a kind of a cyclic process when we move from the initial state to that of the final state, right? We do have certain KR systems, or the knowledge representation requirements. A good knowledge representation enables fast and accurate access to the knowledge and understanding of that content. A knowledge representation system should have the following properties. What are the following properties? Now, it must have the representational adequacy, it must have inferential adequacy, it must have inferential efficiency, and it must have acquisitional efficiency. What is representational adequacy? The ability to represent. What is inferential adequacy? Ability to manipulate, that whether things can be manipulated or not. In the initial part, representational adequacy is the ability to represent whether the things can be represented or not. In case of inferential efficiency, the ability to incorporate the things, this ability is there or not. Acquisitional efficiency is ability to acquire. So you just need to represent, just need to remember these things. That means the red parts out here, okay, and nothing more. There's a very nice note that has been given here. To date, no single system can optimize all the above properties. You cannot have such an ideal system which can single-handedly solve all this four knowledge representation, or can answer to all these four knowledge representation techniques, right? Now, just a moment. Knowledge representation schemes. While starting up with the semantic net, after this chapter number 8, we have gone through what is relational knowledge. Just to just to revise you out, the four types of knowledge representation are relational, inheritable, inferential, and declarative or procedural. So 1, 2, 3, and 4. Relational knowledge provides a framework to compare two objects based on equivalent attributes. An instance in which the two different objects are compared is a relational type of a knowledge. Inheritable knowledge is something which you are supposed to know. It is obtained from the associated object. That means it is inherited from other objects. So we call it as the inheritable knowledge. It prescribes a structure in which new objects are created which may inherit all or a subset of the attributes for existing objects. From here, the inheritable knowledge, we go for the semantic net representation. And the semantic net representations higher versions are the frames, which you have already gone through, right? Inferential knowledge, it is inferred from the objects through relations amongst those objects. You need not get confused between the inferential knowledge and the inheritable knowledge, right? Now we do have the declarative and procedural knowledge. I'll not be talking about this again and again. You know it well, you know all the examples, and you just need to read it once. Again, there is this part, you have to just read it out. From next class onwards, I'll be starting up with this, right? Now, while we have reached up to this part, you can simply make a note on, you can skip this part, right? You can skip this part, you can skip this slide. You just have to remember this part here. You need to know these particular representations of object, events, performance, meta knowledge, all these things you need to know, right? And just giving you a small revision of all these things. And you need to know the system's competence, system's performance. You have to, you definitely must remember this knowledge representation framework, right? You need to know about why declarative knowledge is describing and why procedural knowledge is doing something. How can you correlate procedural knowledge with tacit knowledge? How can you correlate declarative knowledge with explicit knowledge, right? You have to go through this. You definitely have to go through this diagram, right? I have described it in the difference part, and definitely just run through these previous slides once. Definitely through this, I mean, you need to go through this diagram. Obviously read very precisely about tacit and explicit knowledge. You need to know how things move from data to wisdom. It's all there in lecture number 8. Just pay a certain amount of time on these things, so that in between part, when we have gone through frames and semantic nets and slots, you might have forgot certain things, so just go through it, right? Thanks.